Hey everyone, welcome back for another deep dive. Today, we're going down under to the world of marsupials.
Sounds fun.
We've got our source right here, marsupialwikipedia.pdf, and it is dense.
Oh, yeah.
Get ready to uncover the secrets of these unique creatures, from their, well, kind of bizarre reproductive habits to their epic journey across entire continents. So, when you picture a marsupial, what's the first thing that comes to mind?
The pouch. Right. It's gotta be. Such an iconic feature of these animals, and it represents a totally different way of bringing young into the world compared to, well, us placental mammals.
It's true, you don't really see a kangaroo dad pushing a stroller around, do you?
Nope.
But it's more than just a different look, right? That pouch tells a deeper story about marsupial evolution.
Absolutely. With marsupials, you see their young are born at a very early stage of development. Like we're talking tiny, almost embryonic.
It's hard to imagine something so underdeveloped even, like surviving outside the womb.
Exactly. That's where the pouch comes in. It acts like a second womb, providing a haven where the joey can latch onto a teat and complete its development. This difference in reproductive strategy, giving birth to such underdeveloped young and then providing that external development, is a defining characteristic of marsupials, and it might be one of the keys to understanding their evolutionary success in certain parts of the world.
Okay, so this is where it gets really interesting to me. Because when I think about it, marsupials aren't exactly dominating the planet. I mean, we've got them in Australia and parts of the Americas, but why not everywhere? You'd think such a unique strategy would give them an edge in all sorts of environments.
That's a great observation, and it takes us back millions of years to a time when the continents were arranged very differently. Have you ever heard of Gondwana?
Vaguely. It's like that supercontinent, right? All the land masses like smooshed together.
Exactly. Now picture this. You're a marsupial, let's say an early ancestor of today's opossums, or Didelphimorphia. You're living it up on this massive continent, right? But over millions of years, Gondwana starts to break apart like a giant jigsaw puzzle being pulled slowly in different directions.
So these marsupials are hitching a ride on these continental fragments as they're like breaking apart. Where do they end up?
Well, the landmass that would eventually become Australia drifts south, carrying its marsupial passengers with it. And at the same time, another chunk, destined to become South America, is also making its way across the globe. This explains why we find marsupials in these seemingly disparate parts of the world today. They were once connected.
So continental drift basically acted as this giant isolation chamber for Australian marsupials, and
Oh.
and with no placental mammals around to compete with.
They had free reign. It's a classic example of what we call ecological release. Imagine a buffet with no lines. You can bet those marsupials were first in line to try everything.
And boy, did they try everything. The Wikipedia article mentions so many different kinds of marsupials. We've got the iconic kangaroos, or Macropodidae, of course, but then things get really wild with wombats, Vombatidae, quolls, Ltshears, and even these gliding sugar gliders, Ptoris breviceps, that look like they're straight out of a fantasy novel.
You're right. The diversity is astounding. And it highlights how adaptable marsupials are. They've evolved to fill just about every ecological niche imaginable in Australia. You've got your grazers, your burrowers, your carnivores, even those gliders you mentioned.
Speaking of gliders, the article mentioned something about them being an example of convergent evolution. What's that all about?
It's one of those fascinating quirks of evolution that shows just how much power the environment has in shaping life. You see, sugar gliders, even though they're marsupials, have evolved a very similar body plan and lifestyle to flying squirrels, pteramini, which are placental mammals found in other parts of the world.
So they both developed the ability to glide because they lived in similar environments with, like, lots of trees.
Precisely. And it's not just their gliding ability, they've also got those big eyes for seeing in the dim forest, and even similar ways of communicating with each other. It's a powerful example of how evolution can lead to similar solutions, even in completely unrelated animals facing similar challenges.
It's like nature has a limited playbook, and sometimes different teams end up running the same plays.
That's a great way to put it. And the sugar glider and flying squirrel are just one example. Remember that extinct marsupial predator, the thylacine by Elacinus cynocephalus?
Oh yeah, the Tasmanian tiger. The one that looked so much like a wolf, even though it was more closely related to a kangaroo.
Exactly. The thylacine is a classic example of convergent evolution. It evolved in isolation on the island of Tasmania, yet it developed an almost identical body shape, Hunkin style, and even skull structure to wolves, which are placental mammals found in the northern hemisphere.
It really makes you wonder, what if things had been different? What if marsupials had been the ones to dominate the northern hemisphere? Would we be looking at a whole different cast of characters in our forests and fields today?
Now, that's a question that keeps evolutionary biologists up at night. It's impossible to know for sure, but it's certainly a tantalizing thought experiment. But even though we find these striking similarities due to convergent evolution, it's important to remember that marsupials still have their own unique evolutionary trajectory. They've developed remarkable adaptations that set them apart from their placental counterparts. And perhaps nowhere is this more evident than in the challenges and triumphs of their early lives.
You're talking about those incredible journeys those tiny joeys make, right? The ones where they climb into the pouch after birth. I've always been amazed by that. It seems almost impossible for something so small and vulnerable.
It's a true testament to the power of instinct and adaptation. Imagine this. A newborn joey, blind, hairless, barely larger than a jelly bean.
It's incredible they even survive outside the womb at that point.
Yeah. It is remarkable. This tiny creature, driven by an innate urge to survive, has to navigate its way through its mother's fur, guided by scent and maybe even gravity, to reach the safety of the pouch. And it's not just a leisurely stroll either. This joey is literally fighting for its life.
I can only imagine, like, what are the odds?
And yet they persevere. They reach that pouch, find a teat, latch on, and begin their long journey of development in this secure external womb. It's a perilous beginning, but one that speaks volumes about the resilience of these incredible creatures.
It really makes you appreciate the whole circle of life thing, doesn't it? Those first moments are just as crucial for a marsupial as they are for any other mammal, even if they play out in a totally different way.
Absolutely. And speaking of different ways of life, it might surprise you to learn that marsupials weren't always confined to the southern hemisphere. They actually have a long and fascinating history in the north as well.
Wait, really? I always thought of them as strictly an Australia and South America thing.
That's what's so cool about paleontology. It's constantly challenging our assumptions. Fossil evidence tells us that marsupials were once widespread in North America and Asia, thriving alongside their placental relatives. In fact, the earliest known marsupial fossil, Ltshears, was discovered in Mongolia.
Mongolia? Wow, that's a long way from the Australian outback.
It is, and it just goes to show how much the distribution of life on Earth has changed over millions of years. This little guy, Ltshears, dates back to the late Cretaceous period, around 70 million years ago. That's the time of the dinosaurs.
So we're talking about a time when T-Rex might have stepped on a marsupial and not even noticed?
Exactly. Now, to be fair, Ltshears wasn't exactly a kangaroo. It was a small, weasel-like creature, but it's a crucial piece of the puzzle, showing us that marsupials were once far more widespread than we thought.
So if they were doing so well in the north, what happened? Why the big decline?
That's the million-dollar question, and unfortunately, we don't have a complete answer yet. It's a bit of an evolutionary mystery. Around the same time the dinosaurs went extinct, marsupials in the northern hemisphere experienced a significant decline.
Do scientists have any theories about what caused this? Was it, like, competition? Environmental changes?
Those are definitely some of the leading contenders. It's possible that placental mammals, with their own unique set of adaptations, began to outcompete marsupials for resources in certain environments. Or perhaps changes in climate or vegetation played a role. It could have been a combination of factors.
It's like a detective story with only half the clues.
Exactly. But that's part of what makes studying the past so fascinating. We're constantly piecing together the puzzle, looking for new clues, and refining our understanding.
So while marsupials were facing these challenges in the north, they were thriving down south, right?
Okay.
Especially in South America, if I'm remembering correctly.
You've got it. South America became a haven for metatherians, that broader group that includes marsupials and their close relatives. And it wasn't just a refuge, it was a hotbed of evolution. Isolated from most placental mammals, marsupials in South America diversified into an incredible array of forms, some of which might seem strangely familiar.
You're talking about those convergent evolution examples again, right? Like those saber-toothed marsupials we talked about earlier.
Exactly. Take Stylocosmolus, for example. It wasn't a cat, but it had those incredibly long, saber-like canines that would give any saber-toothed cat a run for its money.
It's like nature has a sense of humor, coming up with similar solutions in such different branches of the animal kingdom.
I agree. And it wasn't just saber-toothed predators. South America was home to a whole menagerie of fascinating marsupials. There were these wolf-like boar hyenids, some of which grew quite large, and even these bear-like creatures called cladocyptus. It was a truly unique ecosystem.
It's incredible to think about these lost worlds and the creatures that inhabited them. It makes you wonder if there are even more surprises waiting to be uncovered.
There undoubtedly are. And, speaking of surprises, there's one little South American marsupial that's particularly intriguing. The Monito del Monte, Dromaeosaurus scleroides.
Ooh, yes. I read about that one. Isn't it that tiny mouse-like creature that's actually more closely related to Australian marsupials than to its fellow South American opossums? It seemed kind of out of place.
It's a bit of a zoological enigma, that's for sure. And its presence in South America, while its closest relatives are found all the way in Australia, tells a fascinating tale of ancient connections and long-distance dispersal.
So how did this little marsupial end up as the odd one out in South America? Was it another continental drift scenario?
You got it! Remember that giant marsupial taxi service we talked about earlier? Well, the Monito del Monte is a living testament to that ancient journey. It's a relic of a time when the continents were connected, a lone survivor of a lineage that once spanned Gondwana.
It's like finding a piece of a puzzle that you didn't even know was missing.
Precisely. And it highlights how much we can learn about the past by studying the distribution and relationships of living creatures. The Monito del Monte isn't just a cute face. It's a window into millions of years of evolutionary history.
That's amazing. It's like having a direct link to that lost world.
Mm.
But let's get back to Australia for a moment. We've talked a lot about South America, but Australia is really where marsupials hit the evolutionary jackpot, right?
Absolutely. Australia is like marsupial central. They've radiated into an astonishing array of forms, filling just about every ecological niche imaginable.
And this is all because they had a free pass, evolutionarily speaking, with no placental mammals to compete with.
That's the prevailing theory. See, for millions of years, Australia was geographically isolated, much like it is today. This isolation meant that placental mammals, for the most part, didn't make it to Australia until relatively recently.
So it's like a giant open house for marsupials. No competition, just endless opportunities.
Exactly. This phenomenon, known as ecological release, allowed Australian marsupials to diversify and thrive without facing the same pressures from placental mammals that their northern counterparts did. And the results, as we can see today, are nothing short of spectacular.
From kangaroos to koalas to Tasmanian devils, they've definitely made the most of it. It makes you wonder, though, what would have happened if things had been different? What if placental mammals had made it to Australia earlier? Would marsupials still be as dominant?
That's a question that has fueled countless scientific debates. It's impossible to know for sure, of course, but one thing's for certain. The story of marsupial evolution is a testament to the power of isolation, adaptation, and a little bit of luck.
It really makes you realize how interconnected everything is, doesn't it? The movement of continents, the rise and fall of different groups of animals. It's like a giant complex dance over millions of years.
Exactly. And just like in any good dance, there are always surprises and unexpected turns. But as we've seen with marsupials, they've been able to adapt and survive through it all. They've weathered countless storms, from climate change to asteroid impacts to the arrival of new competitors. It makes you wonder, what's the secret to their resilience?
That's a great question. I mean, they're facing some pretty serious challenges today, especially with, habitat loss and climate change.
You're absolutely right. These modern threats are unlike anything they've encountered before, at least in terms of the speed and scale at which they're happening. And this is where understanding their evolutionary history becomes crucial, not just for satisfying our curiosity about the past, but for helping to safeguard their future.
So you're saying that by studying how they've adapted in the past, we can get clues about how to help them survive in the future.
Precisely. For example, by looking at how marsupials have responded to past climate fluctuations, we can gain insights into how they might cope with the current warming trend. This information can be incredibly valuable for conservation efforts, allowing us to develop strategies to mitigate the impacts and protect vulnerable populations.
It's like using their evolutionary playbook to help them navigate the challenges of the 21st century.
Exactly. And it's not just about their past environments. Even their unique reproductive strategies might hold clues for human health and medicine.
Wait, really? You're going to have to explain this one.
Believe it or not, scientists have been studying the milk of marsupials like Tasmanian devils, and they've discovered some incredible things. It turns out that marsupial milk is packed with these powerful peptides that have antimicrobial properties.
Antimicrobial, meaning they can, like, kill bacteria and other microbes?
Exactly. These peptides are like tiny, natural antibiotics, and some of them are even effective against bacteria that have become resistant to our conventional antibiotics.
Wow, so those little joeys are basically swimming in a cocktail of super medicine.
In a way, yes. And scientists are now working to synthesize these marsupial peptides in the lab with the hope of developing new treatments for drug-resistant infections. It's a perfect example of how studying the natural world, even the seemingly strangest corners of it, can lead to unexpected breakthroughs.
That's amazing. Who knew those adaptations that helped marsupials survive for millions of years could hold the key to solving some of our most pressing medical challenges? It just goes to show that there's still so much to learn from these incredible creatures.
Absolutely. Marsupials are more than just cute and cuddly creatures. They're living libraries of evolutionary history. And they hold secrets that could benefit humanity in ways we're only beginning to understand.
It's a good reminder that we're all part of this grand tapestry of life, and that by understanding and protecting biodiversity, we're ultimately protecting ourselves as well.
Well said.
So, as we wrap up our deep dive into the world of marsupials, we're left with a sense of wonder at their resilience, their diversity, and the incredible journeys they've taken over millions of years. From those first precarious steps of a newborn joey to the potential medical marvels hidden in their milk, marsupials continue to surprise and inspire us. And as we've seen, their story is far from over. So here's a final thought for you to ponder. What other secrets might these remarkable creatures hold, and what can we do to ensure that they continue to grace our planet with their presence for millions of years to come? Until next time, keep exploring, keep asking questions, and never underestimate the wonders that await in the wild world of nature.